right, here we go. Okay, so we're going to talk about reaction mechanisms now. Again, we've talked about the fact that these reactions typically don't begin in a single, or don't happen in a second step, in a single step. In reactions involving multiple steps, the overall reaction occurs in a series of reactions. We talked about those being elementary step reactions last week. And when we combine those elementary reactions together, that gives us our overall reaction. So for example, here we were breaking apart this ozone into O2 and O. Yeah.
I need a timeout.
Okay.
Where are the carbons?
They're at my house. But they're made. They're coming in.
Yes.
Yeah.
I heard all about it. Sorry. I was excited.
I made you caramels and fudge. Okay.
Mm-hmm.
How much do you want for those?
No. So.
Can I get you to bake me stuff?
Oh, just because that's the last day Libby will be here. Yeah, let's all bring in treats.
That's fine.
Can we just have a party?
Come on, Dad.
Screw this whole chemistry thing. Let's just have a party.
So, anyway.
That's a review day.
Yeah, it's a review day. Yep.
It's a review
So eat
day.
treats and review.
Yeah.
It's a review.
Yep.
Cocoa and cram.
We all know it's not review.
Cocoa and cream. Yep. That's right. Okay. So, this O3, this ozone is going to break down into O2 and an O, and then that O is going to go down in here, combine with another O3, and form two O2s. And so this oxygen here is known as what? What do we call that when it forms? Intermediate. Yep. So intermediate item here. So we're going to get rid of that guy, and he's not going to show up in our overall reaction. So when we get rid of him and then we add these together, we would have 2 of these and we would have 3 of these formed. Okay. So that intermediate then is gone and it's being consumed. So we're not going to show it in our overall reaction, but it actually exists. Conversion of ozone to oxygen then can be sped up if we add in some chlorine. So you add in chlorine as just chlorine, and then you're going to form this. So you're going to take that ozone, add the chlorine in. It's going to form ClO and O2. That ClO then gets fed down to here. It's going to come out with oxygen, and then chlorine is going to be left behind. What is this chlorine? I kind of touched on it a little bit last week. That's called a catalyst, right? So it begins here and it ends in the final step. And then that catalyst just keeps getting reused over and over again. In biology, these catalysts are known as enzymes, and typically they end in the suffix. Anybody know? ACE, A-S-E, yep. Okay, so here's our overall reaction present. They're gonna, we wanna figure out what our overall reaction is by combining these steps and eliminating catalysts and intermediates. So let's see if we can do that. Hopefully this will let me mark on it. Yes, it's showing up. All right, so we're gonna figure out if we have any catalysts. So I have N2O here to start. So it doesn't look like we have any catalysts. So we don't have to worry about that. But we do have an intermediate. What is our intermediate that we need to get rid of? Oxygen. So this oxygen is going to go out of our overall because it started here. It got consumed again. And now we're going to combine our reaction together. So these two will come together. So we're going to have 2N2O. And that's all we have on that side. Then we're going to go over here. I have 2 of these, 2N2 plus, and then I've got my O2 here. Okay. So when you're done, you need to go back and make sure that everything balances, because if this doesn't balance as an overall reaction, you goof something. So I have 4 N2s here. I've got 4 on this side, and I've got 2 oxygens and 2 oxygens. So we're okay there. Now, we didn't have a catalyst, so we don't need to identify anything there. But our intermediate is oxygen. we have our mechanism here. We've got two proposed examples here, and this is our overall. They want to know which one is correct. So what we're going to do is we're going to look and see when we combine this guy and when we combine this guy, which one looks like this. So go and see if you can do that.
Olivia, what time is it now?
We are chemists. Not just we only are
I think I'm ready for the eight.
No, you're not.
I think I am.
No. Oh. 9,
And we're on what?
5.
Halfway there.
We're cruising.
We are really cruising.
And aren't we finishing 6 before it's semester?
Yeah, so we're going the last semester is just three chapters.
Well, that's because
Are
the
they the worst
AP test is like an April
Are they the worst?
It's in May.
or May.
What do we do?
7 and 8 are the worst. 8 especially.
What is it about?
Equilibrium, acid-base equilibrium.
Is that what most of us are?
No, it's right there's the breakdown right next to you. You can see what it's.
Come on, Matthew.
Oh, wait.
Bro, that was long. Yo.
Chapter 3 looks like there's a lot.
Chapter 6 is
a lot.
All right, did you figure out which one of these is valid?
Mechanism 2.
Okay, why is mechanism 1 not valid?
Because there's three.
And what else?
It's not right.
What's missing?
Oh, two.
Oh, two.
Yeah. So mechanism 1 is not valid. Mechanism 3 would be. You have 2 NOs here. That's these. You have your O2 that you need, and you have your 2 NO2 that comes out. Okay. So this guy here is not valid for a number of reasons.
Not valid.
All right. Mechanisms, reaction mechanisms, and rate laws then. Okay. The speed of a reaction is limited by the speed of the slowest step of the reaction. We talked about that. The slowest step then is the rate limiting reactant. In each case, the first step is the rate limiting, or where all reactions are reversible, the rate law of the overall reaction is determined by the rate law of the slowest step. So we talked about those rate laws and how we can use the elementary reaction and look at the stoichiometry to be able to figure out what's going on. So the reaction mechanism here is going to show that this is the slow step, and they've got to tell you that, okay? So you can't just like be given these and then not give you any of this stuff and you just know. So that doesn't work. So here they're telling us that the first step is the slow step. That's the rate limiting step. And that then is going to determine your rate law. So remember, rate equals K, which is your reaction constant, times the reactants of your slow step. So that's the NO and the Cl2, no stoichiometry or no powers there because they're both ones. All right, here again, we've got another example. So our rate is going to equal H2 in brackets and then O2 or NO in the other brackets. Here, well, it does in your overall reaction, but this is your rate determining step. This is what's going to determine your rate. This is your Jaden and your Matthew. This is what's going to slow you down. Okay. All right. So here, use the rate mechanism shown below to determine the rate law for this. So this is my slow step. So my rate law is going to involve these two things right here. So my rate law is going to be rate equals K. What's wrong?
Beautiful question.
There's a catalyst.
It's the I.
Yeah. Rate catalysts are in the rate laws. They just don't appear in the overall reaction.
Wonderful. Absolutely.
Okay,
I did it.
good.
I did it. Yay! She's unreal.
All right, let's try the next one. All right, here they're telling us that the rate law is this, and they want to know which one is the slow step. So you're going to find the rate law that matches this. Does oxygen appear in this rate law?
No.
No? Then that means that this is your slow step. Right? Here, they're telling us that we have our rate law. And when we have our rate law here, we have this as an option and we have this as an option. So they're asking us which one is the correct one. Yeah, this one, if it was up here, it would have this in it, and this would only be, it would be raised to the 1, not written. So it must be mechanism 2 here that is contributing to our rate law, because it just has the NO2 in the rate law. So it has to be these 2 right here.
So how would you justify it by saying that it was a 1?
It has a CO.
It is.
And that's a 0.
Yeah.
And also mechanism 2 because it's slow as well.
So does the reaction here occur in 1 step or 2? 2 steps. This is your slow step. This is your fast step. Okay. That's it for today.
What G would be?
Are
Whoa.
you serious?
Are you
Oh.
serious?
Oh.
All right, look, today's a work on the left.
Oh, I agree with that one. Work day left.
And then going up for questions.
And be prepared, because I'm very.
Question 3, 4, 5.
But